an angle of H, and then I have these points A, B, C, D, and E. And what I need to do is I need to represent 3 areas. And we're going to compare these areas, and we're going to use something called the sandwich theorem. We might not get to that today, but we'll get to it tomorrow. But the first area I want to talk about is the area of triangle ACE. Do you see triangle ACE? I will outline it in red. All right, we'll see you guys after lunch. Come back ready to learn. Come back able to draw, please. All right. So what? We're ready. Yes. Sector. Oh, now it's on triangle ACE, which I've drawn in red, and then sector ACE. What's a sector? Please tell me you remember what a sector is. That's the sector. And then our last one is going to be triangle ACD, which I will draw in green. Yep. Would you agree that out of these 3, which one has the smallest area? The red, the green, or the blue? The red, yep. Yes, yes, we're going to write that in a second. Yep, very good. So this triangle has an area that's less than the sector, correct? And this sector has an area that's less than the larger triangle, correct? All right, then let us write down another important statement. I'm going to decide, I'm choosing, because I can, at this point to work in the unit circle, which means that has a length of 1, which as Bo just said, this then also has a length of 1. So AE and AC both have lengths of 1. All right. We now need to compute area. Area of a triangle is equal to 1/2 base times height. Two. We'll do these 2. What's the length of the base of ACE? Everybody see it's 1? Okay, then I just need the height, correct? The height is going to be BE. All right. Now, do I know the length of AB? No, but I do know the length of AE, and then I'm looking at this opposite side. So I'm going to use a trig ratio to write an expression for EB. If we call that unknown, we'll call it a question mark just so we don't confuse the letters. We'll say that the sine of the angle H is going to be equal to opposite, right, which is my question mark, divided by 1, the hypotenuse. Sine is opposite over hypotenuse. So that means sine of H is equal to the question mark, right? You can, but I'm going to run out of room with other stuff I'm doing, it looks like. Okay, so my second part here, I have 1/2 base times height. I have 1/2 base times height. That's sine of H. So if I write this out, I've got 1/2 times the base, which is 1, times the height, which is the sine of H. is less than the sector area, which I'll have to figure out in a second. Let's move over to this triangle. 1/2. What's the base of triangle ACD? Still 1. Let's now find the height. Would you agree that the height is side CD? Very good. Tangent of H. So, question. It's a question mark. Question mark over. It's not a 3. We said so we wouldn't confuse the letters, we'd write a question mark. So sine of H is a question mark, whatever that length is over 1, or just sine of H. Side CD is going to be tangent because now what we're doing is now we're going to try to write an expression for this one. We know that I'll write it now like this. Side CD, tangent of H is equal to opposite, which is CD, over adjacent. What's the adjacent length? 1. So therefore, length CD is equal to tangent. Are you okay with that? All right, so I've got 1/2 sine of H. I've got 1/2 times 1 times tangent of H. Now I just need the area of sector ACE. And you remember from your math that the way I find area of a sector is I take the area of a circle, which is pi squared, and I multiply it by whatever fraction I'm taking. So H divided by the total amount of a circle. What's the total degrees of a circle? 360, or in radians, I would be 2 pi. So theta over 2 pi. That's how you find the area of a sector. What happens to the pi's? They go away. So you're left with this great formula, which is 1/2 theta r squared when you're working in radians. It's just nicer to work in radians. 1/2 theta r squared. So we go back here. What's the radius of this sector? 1. What's theta? H. So you have 1/2 times H times 1. Okay. You don't need the drawing anymore. Now we're only going to do algebra from here on out. It's pretty straightforward. Do you see how we came up with these? The radius is 1 because this sector right here, the blue, 1 and 1, its radius is 1. If we were to continue to draw the circle all the way around, okay, we have a length of 1. So I don't like the fractions. Do you like the fractions? So let's multiply through by 2. And we get sine of H is less than H is less than tangent of H. Ooh, that's kind of cool. So what I want is, again, I want to come up with something like that. Yeah, if you divide by H, you get a 1 in the middle, right? Except what we actually want is we want this thing to be in the middle. Because we're going to use what we call a sandwich theorem. And a sandwich theorem basically says this. We're going to take something and squeeze it in between 2 other things. For example, I'll do a very basic example of it. Suppose you have this. What is x? 4. Is that obvious to you? Hopefully. We're going to do that same thing. We're going to come up with 2 outside values that we know. The inside value we don't know. So we're going to take Kimball's voice. We're going to divide by something. But instead of dividing by h, we're going to divide by sine. Because you know that this limit should come out. What did you decide right away? The limit should be what? 1. It should be 1. So we're going to divide by sine of h. What's sine of h over sine of h? 1. Tangent of h over sine of h. Question, Ashwin. Yep. Well, we don't, I'll get to that, but right now, the area of this triangle, okay, as you look at it, isn't the red one less than the blue one? It's definitely not equal, is it? Okay. Save that. So we can't write equals because we know that. But, what is h going towards? So I'm going to collapse these and make them flat. What's the area of all of them when h is flat? 0. So, well, it's a limit. So it kind of changes things, yes. Right here? No, totally illegal. Totally illegal. What's tangent of h over sine of h? Tangent of h over sine of h is the same thing as sine of h over cosine of h over sine of h over 1. Multiply by the reciprocal. And you can see that in this situation, you're going to get 1 over cosine of h, or as Kimball said, secant. So, okay, whatever Bo said. So we get 1 over cosine of h. I'm going to leave it like that because I'm going to do something. Do you notice the progress I'm making here? I need to come up with a 1, don't I? Because we know that this limit is going to be 1. Second of all, I need a sine of h over h. I almost have that, don't I? All I have to do is take the reciprocal of everything, right? What happens to the signs when you take reciprocals? They flip. Yeah. So if you take the reciprocal, you get 1 greater than sine of h over h is greater than cosine of h. And now, let us let the limit as h goes to 0 of all of them. Okay? What's the limit as h goes 0 of 1? 1. Greater than, can you plug in 0 here? So we have the limit as h goes to 0 of sine of h over h. Can't plug it in yet. Greater than, can you plug in 0 for cosine? What's cosine of 0? 1. So you notice that when you allow h to go to 0, everybody, what happens to the areas? They're all going to be 0. So you can attach the equals. So therefore, if 1 is greater than or equal to the limit of that, which is greater than or equal to 1, what is the limit as h goes 0? Sine of h over h have to be? It has to be 1. We've sandwiched it between two things, and we've been able to use that for a proof. Sandwich theorem does come up. It is applicable in other ways. You want to be able to see it. We will make use of it, but that's the important piece we've come up with here. So in this expression, this sine of h over h becomes 1. That whole time, we were trying to come up with that. What's the only other part we need now? That's easy. Yeah. Can you plug in 0? No, I'm going to multiply by the conjugate. Cosine of h. What's cosine of h times cosine of h? Cosine squared of h. These are high maintenance. And then -1 times +1, -1 over h times cosine of h plus 1. All right. Still can't plug in 0, can we? What is cosine squared minus 1 equal to? No. Now, you want to know what cosine squared minus 1 is, right? So subtract the 1 over. It's negative sine squared, folks. So we'll use that. And here's where some people get confused what to do next. Because can you plug in 0 yet? No. Watch my magic. There's a reason why. Well, we'll see. We'll give you guys a hint. There's a reason why we did that one first. Oh. I've got to get rid of the h, right? So watch me get rid of it. No. Are you okay with that step? I took the sine over there. I just took it off, and I took the h over there. So these expressions are equal. I know what this is, don't I? What is this? Goodness gracious, it's 1 times. Can you plug 0 into here now? What's sine of 0? 0 divided by what's cosine of 0? 1 plus 1 is. So I didn't get an undefined result in the denominator. So this ends up being 0. So we just showed that this guy up here was 0. So therefore, you have sine times 0 is 0. Cosine times 1 is cosine. Therefore, the derivative of sine is cosine. That's the proof. Um, okay, so here's what we want. And these are the two limits. And now you'll maybe remember them better. But this is what we want to memorize. Instead of using h, I just plugged in theta because often theta is used in this situation because we're referring to an angle when we have trigonometric functions. So limit is theta goes 0, sine of theta over theta. We just proved that that's equal to 1. And we proved it by the sandwich theorem. That we stuck it between two other quantities that we knew, and therefore we got a result of 1. And limit as theta goes 0, cosine of theta minus 1 over theta is 0. Now, I just want to be clear, you guys. If you plug in 0, what is the sine of 0? 0, and you would divide by 0. So it's not clear to you, 0 over 0, what is it? It's an undetermined value. We do get 1 out of this. And if you plug in 0 here, the cosine of 0 is 1 minus 1 is 0. So 0 over 0 gives us 1 here. 0 over 0 gives us 0 here. And you can have that. We're going to talk about indeterminate values. But this is a limit, and these are extremely useful. These you must memorize. You will be expected to know that. If that comes up, if somebody says, what's that limit? Good luck trying to prove that. We're going to learn something later called L'Hopital's rule that helps us in those situations, but that's a limit we need to know. These two pieces, essential. Where do they come from? They came from proving that the derivative of sine is cosine and using this. The last piece really is the sandwich theorem and what does that state? How does that work out for us? And we'll be able to figure that out in not too long, okay? So we'll stop right here, but I'm going to show you guys something cool.